Here is a very good problem where we are going to see how we can use acceleration time graph to find velocities, things like that. The question says a particle moves in a straight line, so it's about motion in a straight line, and with an acceleration that varies with time, right? So the acceleration is variable. Acceleration is variable, but it is in steps. So it is from 0 to 2 seconds is 0, from 2 to 4 seconds is 3, and 4 to 6 seconds is 6 meter per second square. Okay. Since the initial velocity of the object is 2 meter per second, so our initial velocity is 2 meter per second, and we have been given acceleration time graph. So now we look at the question. Find the maximum velocity reached in the first 6 seconds of the motion. So all the way up to here, what is the maximum velocity achieved? Now, initially the problem looks very tough, but if you know that an acceleration time graph, right, the area under the curve is going to give us the change in velocity. We know that we can simply calculate this area, and that is going to be the change in velocity, right? So my final velocity is going to be initial velocity plus this change. Okay, so let's calculate this area. Here it is 0. From here to here, this is 2 units, and the height is 3. So this area is 6. From here to here, 4 to 6, again 2 units, and the height is 6. So this area is 12. So in total, the change is going to be 2 plus 12 plus 6, which is 18. So the final velocity which the object will have will have 20 meter per second. Okay, as simple as that. Now draw a graph of the velocity against time. So this is going to be easy. So we have this time, we are going to call 2, 4, and 6. So initially, from 0 to 2, there is no acceleration. So it will have the same velocity with which it is traveling. So this is going to be 2, right? So no change in the acceleration. From 2 to 4, there's an acceleration. So the velocity is going to change from initial 2 to 6, which means 8, right? So we can go all the way up to here, and up to 4, it is going to be 8. And because it's a constant acceleration, this could be inclined line like that. Okay. And this value is going to be 8 meter per second. From 4 to 6, the acceleration is again going to change the velocity, and this time by 12 units. So we have to go further up. So let's say this is 20, right? So at 6, we are at 20, and we'll have a steeper slope like that, and that is going to be our VT graph. So this is how we can use the concept that area under the acceleration time curve is going to give us the change in velocity to solve this problem pretty quickly.